Emerging autonomous driving applications are setting the pace of the innovation for the onboard positioning systems. In this context, safety is a fundamental requirement and the greatest concern. A new class of automotive GNSS receivers and positioning architectures is needed. The Escape GNSS engine offers a market-oriented answer to these needs through two key aspects: the smart exploitation of different localization data sources to provide a highly accurate navigation solution, and the provision of a real-time integrity information, indicating the degree of confidence in the estimated location. Escape exploits the latest GNSS technology and the Galileo differentiators to enable safety-critical autonomous driving applications. Escape is funded by the European GNSS Agency, GSA, under the Fundamental Elements program. The core of the Escape GNSS engine is a Galileo-enabled GNSS receiver, a dual-frequency multi-constellation chipset designed for the first time in the market with specific targets of functional safety for automotive. GNSS positioning measurements, together with inertial sensors and vehicle data, improve the availability and continuity of the position information, while cameras extract lane marks to provide lateral constraint. When the board is connected to an external data server via 4G data link, the accuracy is further improved thanks to PPP processing. The Precise Point Positioning Service exploits precise corrections for the GNSS measurements without the need for complex local infrastructures. The position information is provided continuously with the associated level of confidence, also known as the integrity level, to implement autonomous navigation. The GNSS receiver integrated in the board is the new ST Microelectronics Teseo APP. The Teseo APP processes at least 2 frequency bands from multiple satellite constellations at a time and is able to support future 3 bands application, signal authentication, and the commercial service. In this way, the receiver provides the host system with the full potentiality of the Galileo bands and user services. The Teseo APP also responds to functional safety requirements for automotive safety integrity level, ASIL-B, with stringent performance on the fault-tolerant time interval and on the capability of detecting unavailabilities, exploiting its embedded safety mechanisms. The safety-centered design of the Teseo APP is the basis for the safety-centered design of the whole Escape GNSS engine. The whole architecture of the hardware has been engineered by Ficosa, following the most recent practices in the design of automotive electronic control units. In the perspective of safety, the specification and design of the board has followed recommendations from the ISO 26262 standard. The enhanced localization functions are achieved applying data fusion algorithms developed by GMV, which blend GNSS, inertial, and motion measurements. This approach ensures continuous position information, associated with its level of confidence that bound positioning errors all the time, that is to say, the integrity level. The onboard cameras allow the determination of the motion lanes on enhanced road maps to provide lateral position constraints, while the PPP algorithms target centimeter level accuracy. The Escape GNSS engine is designed to be integrated in vehicle OEM solutions targeting autonomous driving. The Escape solution was validated at the University of Technology of Compiègne in France in collaboration with Renault, using the sensors and map that are deployed in their current autonomous vehicle prototypes. The vehicle demonstrated its capability to move autonomously in controlled environments and public roads. The Escape roadmap includes actions towards standardization and certification, in charge of the French institute IFSTAR. Different countries and national organizations are gradually converging towards standardization in the autonomous vehicle domain. Escape has interacted with the Pan-European Sensenelic Technical Committee 5 Working Group 1, received guidelines for the execution of standard performance tests, and, at the same time, providing feedbacks to the standardization group from an industrial perspective.
The Escape GNSS engine is an electronic control unit which is expected to contribute to a breakthrough in the GNSS technologies. Until today, having a dedicated ECU for positioning was not a usual practice. But when it comes to accurate and precise positioning, the complexity of the system justifies having such an ECU, more taking into account the safety requirements of a unit like that. Furthermore, the OEMs could see also the opportunity to integrate escape functionalities in another ECU with additional capabilities that leverage on escape ones. In this view, we have a Tier 1 product with enough flexibility to adapt to any vehicle's architecture. At the end, whichever architecture is implemented, we see the Escape GNSS engine as a primary actor for the future driving automation technologies market.